Welcome to the technical presentation on the tekmarNet Thermostat 553. Is the 553 the right choice for your application? My name is Elizabeth Brown. I am a technical support specialist at Tekmar Controls, and I will be your host for today's webinar. This is the second webinar in the tekmarNet Thermostat 553 presentation series. The introductory level webinar, which also includes comparisons on all Designer Series thermostats, is available for viewing on the Tekmar YouTube channel. You can just search Tekmar video on the YouTube channel to find all of our webinar presentations. The 553 is a configurable thermostat that can support 2 stages of heat, 1 cooling stage, with options for fan and humidity control. This presentation will go more into depth on the wiring and the programming that is needed to customize the thermostat for your application. We'll start by reviewing some of the concepts that we introduced in the introductory presentation, the array of equipment that the 553 can control, and the relay configuration that limits the different equipment you can use simultaneously. Then we'll take a look at the humidity control settings. These are mostly consistent with the 557 that you're already familiar with, but there are a few exceptions that we'll discuss. We'll look at the electrical diagrams and the settings for the featured applications of the 553 and really make sure that you're comfortable with the relay configuration and the wiring. Lastly, we'll go over additional settings in the Setup, Set Temp, and Toolbox menus. The 553 can control up to 2 stages of heat, and those 2 stages of heat can have heat terminals of radiant floor, fan coil, convector, furnace, and backup heat. So unlike the 557 where your first stage of heat is limited to radiant flooring, on the 553 you can actually choose the heat terminals for each stage of heat if you're doing a 2-stage heat application. You also have the option to control a fan and a humidifier or dehumidifier. And we have the option to operate a 1-stage heat pump or air conditioner. So there is a lot of equipment compatibility for the 553, but you have to remember you cannot control all of these pieces of equipment at the same time. And that has to do with the relay configuration for this thermostat. So let's review the relay configuration. You can see right away why this thermostat is so flexible. We can control a lot of different pieces of equipment with these relays. The accessory relay can be configured to operate your 2nd stage of heat, a humidifier, a dehumidifier, a fan, or an HRV. So we have 5 options for a single relay. Your Y relay can operate a heat pump, an air conditioner, or a humidifier. So if your accessory relay was not set up to operate a humidifier, you could still use the Y relay to operate one, but it would come at the expense of a heat pump or air conditioner. So right away we can see, yes, we do have a lot of options for equipment, but we also are limited in what we can operate at the same time. Our GO relay can be set to operate a fan, or if you're using a heat pump, it would control the reversing valve. We will review this relay configuration later in the presentation. The 553 has an internal humidity sensor for relative humidity control. So just like the 557, there is that onboard humidity sensor. However, unlike the 557, you cannot connect an auxiliary temperature and humidity sensor 086 to the 553. So there are no terminals to connect that external humidity sensor. You are limited to the onboard sensor. Over the next few slides, we're going to take a look at the humidity control function of the 553. Let's review the concept of relative humidity. It is the moisture content in the air compared to the potential moisture content in the air at the given temperature. So relative humidity changes with the air temperature. If you look at the slide, at 10 degrees Fahrenheit, this amount of water in the air might translate to 100% relative humidity. If we increase the temperature of the air to 40 degrees Fahrenheit, that same amount of water might translate to 30% relative humidity. And if we increase the air temperature again to 80, that same amount of water could be 10% relative humidity now. So it does change with air temperature, and that's because the warmer the air is, the more thermal energy that is available to evaporate the water molecules. Now, why is it important to measure and control relative humidity? This is a study that was done in 1985. It is published in the ASHRAE Transactions Handbook. Now, we can see in the study it was shown that the optimum level of relative humidity ranges from 30 to 60%. So this is your optimum zone for relative humidity. When we are outside of that optimum zone, then we will have more problems with bacteria, viruses, biological organisms. You will also see a greater incidence of respiratory illness and infection. So it is important for us to control relative humidity because it's important for our health and our comfort. How does the 553 control relative humidity? Well, it's controlled using the humidity minimum and maximum settings that you input into the thermostat. So if we drop below our minimum setting, then we can enable a humidifier. If we rise above our maximum setting, then we can enable a dehumidifier. And you can see our defaults in this thermostat match the optimum range that I showed you earlier. So our default minimum is 40%, our default maximum is 60%, but we do give you a range. So if you want to go outside of that optimum area, you can. Our minimum range can go from 20 to 80, as can our maximum range. There are 3 humidification modes in the 553. These are the same modes that are in the 557. Humidification mode 1 will enable a standalone humidifier. So this is a piece of equipment that is not in the ductwork. Humidification mode 2 is a humidifier that will require a fan for operation. And an example of this, as shown on the slide, is a steam injection humidifier, where water is boiled and steam is injected into the duct. Now, we do need that fan to carry the moisture in the air to the space. Humidification mode 3 is a humidifier that requires the air heating to be on for operation. And an example of that would be drum humidifiers with evaporative pads in duct installations. So we require forced air heating and fan operation for the furnace air to pass over the humidifier pad, evaporate the water, and carry that moist air into the space. There are 3 dehumidification modes in the 553. So you'll notice in the 557 we had 5. Now we have 3 for the 553. We have dehumidification mode 1, which will enable a standalone dehumidifier that is not part of the ductwork. We have dehumidification mode 2, which will operate a DX coil to condense water out of the air for dehumidification. Now, because we're using that DX coil, we can only use dehumidification mode 2 in the summer when we're cooling. And our third dehumidification mode will operate an HRV for dehumidification. Now we're going to look at the coil and the HRV dehumidification in greater detail over the next couple of slides. So this has changed slightly from the 557. When we were doing coil dehumidification with the 557, we required a duct sensor be present. Now it is an optional feature to use that duct sensor. So we still allow the room temperature to fall 3 degrees below the set point before we stop the dehumidification process. And if you install the optional duct sensor 083, we can provide freeze protection to the DX coil. So in the event that the duct air temperature nears freezing, the thermostat will remove the dehumidification signal, but the cooling compressor will continue to operate together with the fan operating at full speed. Now this fan operation would be controlled by the air handling unit. It's not controlled by the 553. And that fan will allow the DX coil to warm up. So the freeze protection is available if you install the duct sensor 083, but it is not mandatory. We are going to look at this in one of our applications later in the presentation. Dehumidification with an HRV is the same operation as it is with the 557. So an HRV can provide dehumidification when the outdoor air is at least 5 degrees below the indoor dew point temperature. So if I look at the left-hand side of this slide, my outdoor air temperature is 50 degrees. My indoor dew point temperature is 57. So in this case, my outdoor temperature is greater than 5 degrees below the indoor dew point. So my HRV will be allowed to operate for dehumidification. If I look at the right-hand side, I've been operating this HRV for a while now, and now the indoor dew point is 52. My outdoor temperature is still 50. Once there is a 2-degree separation between the indoor dew point and the outdoor air temperature, we turn the HRV off, so it will not be providing dehumidification any longer. You can see, though, it had quite an effect on our relative humidity. We went from 62% to 51%. So the HRV dehumidification is very effective. Because of the conditions that surround the operation of the HRV, it really is something that can only be operated during the winter. So we have our coil dehumidification in the summer, and we have the HRV dehumidification for the winter. Now we're going to look at the featured applications for the 553. Now remember from the introductory presentation, we want you to select this thermostat based on the application. Do not select the thermostat based on the features because, as you saw before, those features are not constant. They really depend on the relay configuration. The relay configuration one more time before we look at the applications. Our accessory relay, remember, can be set up to operate the second stage of heat, a humidifier, a dehumidifier, a fan, or HRV. Our Y relay can be set to operate the heat pump, air conditioner, or humidifier. And that heat pump and air conditioner are single stage units. And our GO relay can be set up to operate a fan, or if we are operating the heat pump, it can control the reversing valve. Now let's look at our first application. This is a one heat, one cool with fan and relative humidity control application. So we have one stage of heat that's coming from our furnace, and that's going to be operated with the W relay. Our fan will be operated with the G relay. We have one stage of cooling here from the air conditioner. That will be operated with the Y relay. And our accessory relay will be set up to operate the humidifier. We could also set that up for a dehumidifier. Now let's look at the wiring for this application. This is a standalone application. It's a strictly forced air application, so we are not connected to a house control or a system control or a wiring center, just a standalone application. So we have power coming in from the furnace, C and R. There's been a jumper installed from R to RH to provide power to that W relay. And the W is coming back to the furnace. Now we've also added another jumper to the RC. Now the RC is attached to the accessory, the Y, and the GO. So our accessory is coming back to operate the humidifier. The Y is coming for the air conditioner, and we have the G coming in for the fan. We've also shown how you could take this standalone application and connect a tekmarNet device. So we have the TN4 coming to our tekmarNet device and the C coming back to the furnace. The settings here, Y is set to air conditioner, W is set to furnace, our accessory relay is set to humidifier, and the GO relay is set to fan. Now let's look at our second application, which is a two-heat application with fan and humidification. Now notice when the title specifies humidification, that is because we can only operate a humidifier. When the title says relative humidity, that means we can operate a humidifier or a dehumidifier. So look to the title because it will tell you what equipment specifically we can operate in this application. So in this 2-heat application, our first stage of heat is the radiant floor. So we have the W going to the house control for the operation of the radiant floor. Our second stage of heat is the fan coil. Now this will be operated from the accessory relay. Remember, we can set that accessory relay to W2. So that accessory relay will come over to a wiring center to operate that second stage of heat. We have the Y relay configured to operate the humidifier. Now this is why we are restricted in this application to humidification, because that Y relay cannot be configured to operate a dehumidifier. It can only be configured to operate a humidifier when we're doing humidity control. We also have the G relay for the fan operation. You'll notice here the coil sensor 082. Now this is an optional sensor that we could use in this application. And if we use the coil sensor, we can set a fan coil min setting. Now that fan coil min setting would be used to prevent cold air from blowing into the space. And we'll look at that setting more later in the presentation. Now let's take a look at the wiring. Our first stage of heat, the radiant floor, will be communicated through the tekmarNet communication. Our second stage of heat, remember, that's through the accessory relay. And that is not an isolated relay. That is connected to the RC. So we have power coming from the air handler unit, coming to that RC. And then our accessory relay will come over for our stage 2 control. Now this would be a TN4 wiring center or a zone manager. So the accessory relay comes into the W. Now this is a little bit different. In this case, we leave the R empty. And we're going to bring the C to the C at the air handling unit to complete the circuit. So a little bit different in this case because we're not connecting anything to the R, which is what we normally do for this type of application. But because that accessory relay is not isolated, it is tied to an R already from the air handler unit, we're not bringing it into the R on the TN4 device. Our Y is going to go to control the humidifier at the air handler, and the G for fan operation. And here we're showing you the optional coil sensor and an optional outdoor sensor. The settings for this, Y is set to humidifier. Our W is set to HRF, so HRF 1 or 2, depending on what type of flooring you're using. Our accessory relay is configured for W2. We're doing second stage heat here. What terminal is our second stage heat? It's a coil. And our GO relay is set to fan. We're going to look at the TN4 wiring only for this application because it does get repetitive, but we'll show you the slight variation if you're using a TN4 device. The first stage heat is still communicated with the tekmarNet, but now it's tekmarNet 4. So we have TN4 to TN4, C to C. Our R is coming into the R. We have a jumper R to RH, and then the W will come to the W on the TN4 control. The rest of the wiring will be the same. So the second stage heat, we still have that accessory relay coming in to the W of the TN4 wiring center or zone manager. We still leave the R empty, and we bring the C to the air handler to complete the circuit. Y is going to the humidifier, G to the G for fan operation. Now we'll look at our third application. A 2-heat, 1-cool with fan operation, and this is going to be a furnace application. So we have 2 applications that feature 2-heat, 1-cool, 1-fan. This first one will show you the configuration for a furnace. So our first stage of heat is the radiant floor. We can see the W coming to a wiring center for the operation of that radiant floor. Our second stage of heat, through the accessory relay, will operate the furnace. We have the G for the fan and the Y for the air conditioner for cooling. Let's look at the wiring. So our first stage of heat is communicated through the TN2 to the wiring center in this case to operate the radiant floor. We have the R coming from the air handler. It's tied to the accessory relay going to the furnace for second stage heat. It's also tied to the Y relay going to the air conditioner for cooling. And it's tied to the G for the fan operation. We're showing you an optional slab sensor for the radiant floor and an optional outdoor sensor. Now let's look at the settings. Y will be configured for air conditioner. W is set to other. The reason it's set to other is because we're showing you the use of a wiring center for the radiant floor. If we were showing you a house control, then you would set it up for HRF1 or HRF2. But when you connect it to a wiring center, you lose that option. So you will set it to other. The accessory relay will be configured for W2 because we're doing a second stage of heat. That second stage of heat is a furnace. And our GO relay is set to fan. Our fourth application, which is another 2 heat, 1 cool with fan. Now this time, it's a fan coil, not a furnace. So our first stage of heat, the radiant floor, we see the W going to a house control. Our second stage of heat is the fan coil. So the accessory relay is going to the wiring center to operate the fan coil. Our Y will operate the air conditioner for our cooling stage. And we have the G for the fan operation. Now to take a look at the wiring. The radiant floor communicated through the TN2 to our house control in this case. Our second stage of heat is through the accessory relay. So we have the R coming in from the air conditioner, the accessory relay for our second stage heat coming to the W on the TN4 wiring center. R is left empty. And we have the C going to the C on the air conditioner. Y is going to the air conditioner for cooling, and the GO for the fan operation. Here again, we're showing you the optional slab sensor for the control of the radiant floor, and the optional outdoor sensor. Our settings, Y is set to air conditioner. W is HRF1 or HRF2. Now we can set it for this way because we're going to a house control. The accessory relay is set for second stage heat. That second stage of heat is a fan coil. And our GO relay is set to fan. Our fifth application is also our first heat pump application. So this is a radiant floor with heat pump and relative humidity. Remember, when the title says relative humidity, that's because we can control a humidifier or a dehumidifier. So first stage of heat, the radiant floor, we see the W going to the wiring center. Our second stage of heat will be from the heat pump. So our Y is going to the heat pump. And because we're using a heat pump, our GO relay is going to operate the reversing valve. So we have it set to O here in the diagram. Our accessory relay, in this case, will operate a dehumidifier. And we're going to be using the DX coil for dehumidification. So we talked about that earlier. The duct sensor 083 is optional in this case to provide freeze protection for the coil. Notice there is no G relay in operation because we're using the GO relay for the reversing valve. So in this case, the air handler unit is going to operate the fan whenever it receives a call from Y or the accessory. When it is in heat pump cooling, it would operate the fan probably at a higher speed. When we're doing dehumidification, the fan would operate at the dehumidification speed, which would be a lower speed. Now let's look at the wiring for this. First stage of heat is communicated through the TN2 connections. In this case, we're going to a wiring center. Now we have the R coming from the air handler unit. That's tied to the ACC. The ACC will operate the coil for dehumidification, so that will be a dehumidification call to the air handler. Our Y is operating the heat pump, and that could be for a stage of heating or a stage of cooling. And our GO relay is going to operate the reversing valve. We're showing you the optional duct sensor in this case because we want that freeze protection for the DX coil. Now remember, once that duct air temperature nears freezing, we remove that dehumidification call to the air handler and we let that coil warm up. We're also showing the connection to the outdoor sensor. Our settings, Y will be set up for heat pump. W is set up for other. Now the reason is because we're connected to a wiring center, so we don't have the option for HRF1 or HRF2. Our accessory relay will be set up for dehumidification, and the GO relay will be configured for O or B depending on the region where you live. Our sixth application is another heat pump application. This time, the ACC relay will not be operating the dehumidifier, it will be operating an electric strip for backup heat. So this is the only application for the 553 where we have the option of 3 stages of heat. Our first stage of heat is the radiant floor, so we have the W going to the wiring center. Our second stage of heat comes from our heat pump, the Y relay. The GO is obviously going to control the reversing valve for the heat pump. And now my accessory relay is going to operate the electric strip for backup heat. So we have first stage of heat, radiant floor, second stage heat from our heat pump, third stage of heat from the electric strip backup. The first stage of heat is communicated through the TN2 connection. We have the R coming from the air handler. That's connected to the ACC relay, which will operate the electric backup. Our Y for the heat pump operation and the O for the reversing valve. The settings are Y, heat pump. W is set to other, and that's because it's a wiring center that we're connected to, so we don't have the option for HRF1 or 2. The accessory relay is set for W2. Now, what is W2? We are going to set it up for furnace. So it's electric strip backup. We're setting it up for furnace, and I'll talk more about why we chose this setting later in the presentation. Our GO relay will be set for O or B, depending on the area where you live. Our last application, this time the accessory relay will be operating a fan instead of the dehumidifier or the electric strip backup. Our first stage of heat is still the radiant floor, so we have the W going to the wiring center. Second stage of heat from our heat pump with the Y relay. O for the reversing valve, and now my accessory relay will operate the fan. The first stage of heat is communicated through the TN2. We have R from the heat pump. That's tied to the accessory relay. Now the accessory relay is controlling the fan, so it's going to the G. The Y for the heat pump and the O for the reversing valve. So our settings in this case, Y is heat pump, W is other because it's a wiring center again, accessory relay is fan, and our GO relay is set to O or B depending on the area you live in. Now that we covered all the applications, let's look at the menus of the 553. These are the same menus that you're familiar with from the 552 and the 557. We're not going to look at all of these menu items today. Most of them are very self-explanatory. We will look at additional settings in the setup menu, the set temp menu, and the toolbox menu. Starting with the setup menu. What we're going to go into is the relay configuration because that is the big thing with the 553. It can be set up to control so many different pieces of equipment that relay configuration isn't necessarily obvious to begin with. Hopefully at the end of this presentation it will be. So specifically we'll look at the Y relay, the accessory relay, and the GO relay. Other settings in the setup menu that we'll look at are the W, Y, and W2 differentials, the W2 delay, the fan coil minimum, ventilation mode, and floor cooling. So as we saw through the applications, the accessory relay can be set up to operate a fan, an HRV, a humidifier, a dehumidifier. It can also be set up to control a second stage of heat. We didn't show that second stage of heat here because it can be configured for so many different heat terminals. So you have 5 options with the accessory relay. The Y relay will be set up for a humidifier, a single stage heat pump, or a single stage air conditioner. Now notice the accessory relay, the Y relay, the GO relay, none of these are isolated relays. They're tied to that RC. The GO relay can control the fan or the reversing valve. And your options depend on how you can configure the Y relay. If you set it up for AC or humidifier, your options for GO are restricted to fan or off. If you set your Y relay up for heat pump, then your GO relay options are restricted to O or B. So what you see is your options for the GO relay depend on how you've already set up the Y relay. Now let's take a look at the differentials. Our W differential is 1.4. So minus 0.7 from the set heat room and plus 0.7 for the set heat room. Now this only applies if your heat terminal is coil or furnace. So if your W is set up for HRF, then it's going to be a PWM function, not a differential. If your W is set up for convector or other, then in that case it's going to be based on an on-time calculation with an integral. So this differential of 1.4 only applies if your heat terminal is coil or furnace. Let's look at the other side. Your Y differential is also 1.4. 0.7 below the set heat room and 0.7 above the set heat room. So the Y differential is also a fixed differential for the heat pump. The W differential is configurable if your heat terminal is coil or furnace. So the only way you have access to select a W2 differential is if your heat terminal is coil or furnace. And in that case, your W2 differential can be configured for 0 to 8 degrees, and that applies for Fahrenheit and in Celsius, 0 to 8 for both. So when will your W2 turn on? it'll turn on minus 0.7 plus your W2 differential below the set heat room. When will it turn off? Once we're at the set heat room. So this differential is entirely below the set heat room value. So in this case, I'll refer you back to the application where we had the 3 stages of heat with the electric strip backup. Remember how I set W2 to furnace? The reason I did that was because I wanted access to this W2 differential. If I set it to other, I would not have access to configure the W2 differential. W2 delay. Now this is available for all of the heat terminals. It is the minimum amount of time that the first stage and or the heat pump must be operating before W2 can turn on. So 2 conditions must be met. The W2 differential must be met if it's a coil or furnace heat terminal, and the W2 delay must be met. Now we can set this to auto, in which case there is no additional delay. We can set it for a time ranging from 5 to 180 minutes. So if you want to, you can hold that off for an extra 3 hours. Or you can set it to override. And in override, W2 will only turn on when you're in emergency mode. So emergency mode is when your heat pump is not operating. This W2 delay is not applied when the heat pump is locked out. It's not applied when W2 is the only stage available for heating. And it's not applied if the heat pump is turned off in respect of the balance point. So it won't hold off W2 in cases where we need W2. Fan coil min is a setting that is also in the 545. So if you're familiar with the 545 thermostat, you're familiar with the fan coil minimum setting. And that is just to set a minimum coil temperature that must be reached before the fan is turned on, so that we avoid blowing cool air into a space. Now, obviously for this, you will need a coil sensor in your application. Our ventilation mode setting is the same as in the 557. You can set it for auto, in which case the fan will operate with heating or cooling. You can set it for on, in which case the fan is always on. Or you can set it for a percentage of on time, so from 10 to 90%, where each 10% is equal to 6 minutes of on time per hour. So ventilation is also known to some as intermittent fan. The 553 can support radiant floor cooling when it's connected to a 406 house control. So we can turn the floor cool setting on, just like we can with the 552 and the 557. So all designer series thermostats have this function. Now the nice thing about the 553 is if it is controlling cooling equipment and the floor cool setting is on, it can provide a switchover call to the 406. So it has that capacity to provide the switchover call to the 406, whereas the 552, since it's not controlling cooling equipment, it cannot provide that switchover call to the 406. Now, as a reminder, in order for the floor cooling operation to begin, you must be above your warm weather shutdown temperature. So that is a condition that has been set, that you must be warmer than warm weather shutdown to allow floor cooling to begin. In the Set Temp menu is where you will set your heating and cooling temperatures for each scheduled event. It's also where you'll put in your minimum and maximum floor limits, where you will enter your ventilation and humidity control preferences, so your humidity minimum and maximum settings. And this is also where you configure the warm weather shutdown temperature. The Toolbox menu is very useful for troubleshooting. It's always where I begin my troubleshooting. So we see information about the status of the thermostat and other tekmarNet devices on the network. One of the things I like a lot is the status. I can see in the status if the thermostat is in normal operation, if it's overriding the radiant floor because of the radiant floor warm weather shutdown, if we're in floor cooling, if I'm in warm weather shutdown or cold weather shutdown, if I've hit a floor min or floor max, if it's in an interlock wait time between heating and cooling, that will appear at the status item. And if my hydronic heat is off, will also appear at the status. The device count is where I can see all the other tekmarNet thermostats that it is communicating with. We have the offset room temperature. So if you realize you need to offset a room temperature measurement, you have that option with the 553, and that applies to both the onboard room sensor and also if you're using an external room sensor. You can also offset the humidity. I like to see the error history. So it will store the last 5 errors on the thermostat in this history. I can load the factory defaults. I can set it up for notification for when I need to change my air filter. And I can do a user test in the Toolbox menu. So we can select the heat or cool sequence. It will go through a series of tests, and there is a chart on page 6 of the installation and operation brochure that will show you which relays close in which order. In summary, we looked at the humidity settings for the 553. We reviewed the electrical diagrams and the settings for the 7 featured applications. We reviewed the setup menu items. In particular, we looked at the relay configuration. So this is a big change, that the relays can be set up for so many different things. We have a lot of options here, but that also limits us in what we can control simultaneously. We looked at the differentials, and the big thing to remember was that you can only set up the W2 differential if the W2 heat terminal is coil or furnace. W2 delay, which we can set up for up to 3 hours if we choose to. The fan coil minimum to ensure occupant comfort and make sure we're not blowing cold air in a space. Our ventilation mode options, the floor cooling operation. And we looked at other items in the Set Temp menu and the Toolbox menu. In closing, I hope that you feel very comfortable with how you would choose the 553 for an application, how you would configure that for the application you have in mind, and wire it accordingly. If you have any questions or comments, please don't hesitate to contact us. You can send us an email, learn@tekmarcontrols.com, and we will get back to you within the same day. We appreciate your feedback, and it means a lot to us to continue to improve the training that we offer our customers. Thank you for spending the time listening to this webinar on the 553. My name is Elizabeth Brown, and I look forward to hearing from you. Have a great rest of your day.